This video is the first video for Chapter 2 in Anatomy. This chapter is going to go over a review of chemistry. We're not going to highlight every single thing that is in the chapter. You can go on Schoology and find out I'm going to be highlighting certain things that I need to reinforce for class. So the first thing that we're going to look at with chemistry is bonding. So that is what is going to go in this first box. I'm going to break bonding into two main categories. And if you remember from chemistry, these categories are based on how electrons are treated. So the first category that we're going to look at is ionic. And ionic bonding involves the transfer of electrons. And I'm going to abbreviate electrons with a little e minus since they have a minus charge. Usually, these are between a metal and a non-metal pair. So the metal loses an electron and the non-metal gains what is lost. And we have different ratios of those elements. The metal, if it loses an electron, we call it a cation, and since it loses a negative charge, it becomes positive. And the nonmetal is an anion. Remember that the second part of it could also be a polyatomic ion, which is a group, something like phosphate or acetate. We will see those, sulfate, all through the class. And the anion is a negative charge. These are not going, we'll use them, but covalent, the second type, is the one that is more prevalent in what makes up our body. So covalent compounds, we have the sharing of electrons. And these compounds are often called molecules. So, on this, we have two different categories of covalent compounds. We are going to have polar and non-polar. And they have different properties. And when we share atoms in a covalent compound, sometimes one compound pulls the electrons that are shared a little bit more than the other atom. And we end up with a very slight difference in charge on one side of the molecule from another. So in polar, we end up with two poles, one positive, one slightly negative. So the atoms do not share electrons evenly. And it has to do, we have electronegativity differences. So there's a difference in electronegativity that is enough to separate the charges. And usually that's around a 0.4 difference or higher. Nonpolar, the atoms share electrons evenly. So if we have something like H2 or O2, the atoms, because they're the same element, actually pull on them with equal amounts. So it's like having a tug of war with yourself. Nothing's going to move. Now the big thing about polar and nonpolar is polar substances can dissolve other polar substances. They mix. Nonpolar and nonpolar can mix, but polar and nonpolar do not mix. Water is extremely polar. Oil is nonpolar, and we know that oil and water do not mix. So that's an important concept when we talk about our bodies, because we have nonpolar substances in our bodies, and we have polar substances. And everything is going to be about how things interact with one another. If we can control that, maybe we have to get something across a barrier, and it has a polar surface. Well, something that's polar might be able to go through. Something that's nonpolar might not be able to. So, if we look at this, we end up with a very special type of nonpolar bond called a hydrogen bond. And this is between molecules that contain hydrogen and either nitrogen, oxygen, and or fluorine. This is a very strong covalent, I don't want to say covalent, very strong force between molecules. They're actually called intermolecular forces, but you don't have to know that. But in the body, these are extremely, extremely important. These give protein a three-dimensional structure, and we'll talk about that later. This also links the two strands of DNA together. So if you remember where you had A and T and C and G, and we had the double helix, well, what holds A and T together are hydrogen bonds. They're strong enough to hold the DNA together, but we have enzymes that can actually break that molecule apart. So the next video is going to go over the structure of water. Water exhibits hydrogen bonds.